Solving radical equations. Today we're going to be looking at ones that have a radical equal to a radical, which means you're going to have something like the square root equal to the square root. They have to be like radicals today. We're not going to be dealing with any of them that are not like, meaning they're going to have the same index. So let's look at number 1. We have the square root of x over 2 equals the square root of 2x plus 3. So it's going to work very similar to what we were doing first with you isolating where you had to isolate the square root. But the square roots are already isolated. There's an individual square root on each side. So the step 1 is going to be to square both sides. And so when you square a square root, it takes away the radical and leaves you what was inside. So now we need to solve this equation. So I look and see, I could combine like terms by moving the 2x over to the 1/2 x. But then I have to work with fractions. So I prefer, whenever I have a situation like that, I prefer to go ahead and multiply both sides by my common denominator. And it will cancel out that fraction, because that will reduce to a 1, and leaving me just an x there. Equals 4x plus 6. Now I have an equation I can solve. I need to get my variables on the same side, so I move my x's over to the left, giving me a negative 3x. That 6 I didn't do anything with, so it stays the same. Now I am going to solve for x by dividing both sides by negative 3. X is equal to a negative 2. So now I am going to go ahead and evaluate this back into the equation. So I'm going to do the square root of negative 2 divided by 2. Does that equal square root of 2 times negative 2 plus 3? And the reason we have to go back and evaluate and check, besides seeing if we have the right answer, it also gives us a chance to checking for extraneous solutions. So extraneous solutions are the solutions whenever where it does not evaluate back in. Think back to when we had the problems with the absolute value. So this is one, if I was thinking about graphing it, it would be one that didn't cross the x-axis. These two lines, if these two were graphed individually, would not intersect. And that can happen. And so let's look and see what happens here. So negative 1, square root of negative 1. Well, right now, we do not have anything that can show us how the square root of negative 1 is. That is something that can exist. It's an imaginary number. We'll talk about those later. But anytime you have this, that means this is an extraneous solution. So you'll mark that as extraneous. And right now there is no solution that we can work with this. And so if there is another one to test, you would test that one and see, is it give you a real solution? But since there's only one answer to test and that one is extraneous, we do not have a solution here. Let's go back and let's check another one. So going on to problem 2. We already have the square root by itself. There's nothing on either side. It's one square root on each side. So I am going to square both sides. When you square both sides, that leaves you the meat inside the square root. And now we're going to get it to where we have the a by itself. And so we need the a on the same side. You can choose one side or the other to move it to. I'm going to move the a's over to the right-hand side so it's positive. And I have 4a plus 7. Now I'm going to subtract 7 from both sides. And I end up with negative 8 is equal to positive 4a. Divide both sides by 4. Gives me a is equal to a negative 2. So I'm going to go back and evaluate this into the problem. So just like I was checking the last problem, just check for extraneous solutions. So my problem says I have negative 1 minus a negative 2. I wanted to see, does that equal square root of 3 times a negative 2 plus 7. This changes to addition. And so the square root of 1, does that equal negative 6 plus 7? And so does the square root of 1 equal the square root of 1? Yes. I didn't put any negatives into the radical, so this is my solution. So again, a equals negative 2. The variable itself can be negative, but when you evaluate it, you cannot end up with that negative under that radical.